All right, so this is going to be the second video that we do to review. And so hopefully you already had a chance to look at the first video that looked at the key features and equations. So now we're going to look more at, actually, let me just flip to it. We're going to look at how do we write an equation based on some information provided on this transformation. So remember we looked at transformations of the parent function of a um, quadratic function. So let me just put my pin here. We had, let's say our parent function looks something like this, and of course it doesn't, right? And we use this vertex form to see how it was transformed, how it either shifted to the left, right, up, down, became narrower or wider with the dilation, okay? So this information provided would gives me everything I need to know in order to fill in this equation or expression. So it says the dilation, it has a dilation of half. So that means my A is going to equal 1/2. It's translated to the right 3 units. So if I have my graph here, left, right, that means it's going in the positive direction. So H equals a positive 3. And it has a vertex, a vertical translation up 2 units. So my K is going to go up 2, so that's going to be a positive 2. All right, so again, I'm going to plug that information into my equation. A is 1/2 times X minus a positive 3 squared plus 2. And if we were asked to graph that, we can again put in our calculator and see what it would look like, or we could graph it using a table of X and Y values, or just say, okay, this is my vertex. My vertex would be 3, comma, 2. And use that as my starting point, and then with a dilation of 1/2. All right, so now this one here has a dilation of -3. So A equals -3. It has a vertical translation to the left too. So again, of course, it moved here. So I have H equals a -2 because it moved in a negative direction. It has it was translated down 9. So my K is going to be -9 because it moved down 9. So again, I plug it in my equation. AX or A times X minus H squared plus K, and so I have -3 from my A, X minus, right, subtracting a -2, and I'm going to square that, plus a -9, so I'm just going to put -9, right? But this isn't, I could write this a little bit simpler, right? I can now, because I'm subtracting a negative, I can write that as -3 times X plus 2 squared minus 9. And from this, I know my vertex would be -2, -9. I know that my dilation is -3, which means it's going to be narrower than the parent function, and is also going to be facing downward. So it's going to look something, I don't know, maybe like that, versus a parent function that looks more like this, for instance. Okay? All right, so now let's go to the next one. So now we are looking at multiplying polynomials using the box method. Oops, let's see. All right, so I have 3x plus 4 times 2x plus 7. And so I'm going to write that up here, 3x, and it's a positive 4, so I'm going to just put 4. If it were a negative or subtracting a 4, I would do a -4, right? I bring that with it. And I have 2x and 7. So this is the area model of multiplication, right? So I'm just going to multiply the 2x times the 3x, and that would give me 6x squared. 2x times 4 would give me 8x. 7 times 3x is 21x. And 7 times 4 is 28. So I'm just going to change my color here. Let's see. And I'm going to circle the two like terms that I can combine. I can combine the 21x and the 8x. So I have 6x squared plus, well, I could write it all out. Why not? 21x plus 8x plus 828. And again, these are the two I can combine. So I would have 6x squared plus 29x plus 28. Okay. So now let's see. We're going to do this one. Again, I just have positives. So I think I have some that you're going to work with that have negatives, or you're subtracting where you're going to have a negative number here or there, wherever. So we'll just do the same thing. We have 16x squared, 40x, 2x, and 5. And again, I'm just going to combine them here because I realized I'm going to add these two. So it's going to be 42x. So I'm just going to write this out. Right? So we have now multiplied polynomials using the box method. All right, so the next thing we're going to do is factoring polynomials. And I realized I misspelled this the entire time. So we're going to multiply polynomials, and how are we going to do that? Well, remember how we practiced before. We want a number that multiplies to give, two numbers that multiply to give us the product of -7 here, and that would add up, and I'll just change the color, that would add up to give us a -6. They multiply to give us a -7, and they add up to give us a -6. So I'm going to start by listing the factors of -7. Well, -7 is a prime number, so the factors are -7 times 1 and 7 times a -1. All right, those are the basic only two ways to write it. I can put 1 in front or behind, but that's the same. And I want it now to add up to -6. So let's start with this one. 7 plus, well, let's start with the first one. -7 plus a +1. Well, that's the first one, right? And we got it. That gives me -6. 7 minus 1 or plus a -1 would give me a +6. So this would not work. However, this would work. So now I'm going to write it in factored form. I have my x here and my x here. And now I'm going to write -7 in one box. It could be in the first, one parentheses. It could be here or here. And then +1 in the other. So x minus 7 times x plus 1. We can do the same here. I want numbers that would multiply together to give me b, to have a product of b and a sum of -9, right? A product of 8 means I can multiply the two to give me 8 and add up to give me -9. So I'm going to list my factors here. All right, so here, and this is where in fact there was a little bit of discussion in class, I noticed that I have a positive product and a negative sum. Well, the only way that could be is if I have two negative numbers, right? Negative times a negative equals a positive number. That's one of the rules of integers. So that means I have to multiply two negative numbers to get a positive. And if I add up two negative numbers, I can still get a negative. That's really the only way that's going to work for me. So I know both of my numbers have to be negative. So what are the, let's see, the factors of a +8, and they both have to be negative. I have a -1 times a -8, right? I have -2 times a -4, and I believe that's it. Those are the only two factors of, or only 1, 2, 3, 4 factors of 8. So now I want to add them to get a -9. And it just so happens for both of these, the first one we get is it. So I have -1 plus a -8 gives me a -9. Oops, that sort of went off the screen, -9. And here I have -2 plus a -4, that would give me a -6. So if I were to factor this, and I'm just going to put it on top, seeing how I ran out of space on the bottom, I have b, right, because that's the variable in the situation, and this is the one that works. b minus 1 times b minus 8. And if I were to again use either the box method or double distributive property, I should end up with this in standard form. All right, so lastly, we're going to look at the garbage method. So this is something we introduced on Friday, and it's one of the quicker ways that I found to do to factor polynomials with a leading coefficient greater than 1. So in this situation, my leading coefficient is a 6. So the first thing I want to do is multiply my a and my b term. My a and my c term. Let me erase that. I want to erase that. I want to multiply my a and my c term. And let's just say a times c, right? So I have a 6 times a 2. So 6 times 2 is 12. So again, just like previously, I want to now find an answer that has the product of 12, but that adds up to 7, right? Two numbers that add up to 7 and give me a product of 12. So let's see. I like to start by factoring. So I'm going to work my way sort of backwards here. So I have 1 times 12. Well, that's going to give me 1 plus 12 is 13. Too big. 2 times 6. Well, 2 plus 6 would give me 8. Too big. Let's see. 3 times 4. Well, 3 plus 4 gives me 7, so it is just right, right? And I can stop there, basically. Not only will I stop there because there's no more factors, but I've also found the answer. So I know that this is going to be my answer, 3 and 4. So I'm going to go back, and of course this involves a couple more steps than the last one, right? Because we're going to now we know what that empty space is next to the x, but we still got more work to do because we still haven't taken out the trash. So I'm going to have a 3 and I have a 4, right? And I'm using g here. So as my variable, so I'm going to write 6g here and a 6g here. So I want to take out the trash. I want to figure out what is the common or the greatest common factor that I could take out of both of these binomials. Well, I noticed if I just look at the first one, both of these are divisible by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So I can do this first one as 2g plus 1 because they're both of these terms are divisible by 3. So I basically factored out a 3 of that one and then threw it away. Now I'm going to look at this next one. It looks like both of these are divisible by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So again, I factored out a 2 of both of these and I took it out. So I can go back and double check. In fact, I think I will. And I'll use the box method just to check to see if this is actually going to give me this expression. So I have 2g and 1 here. And I have 3g and 2 here. And so 6g squared and 3g, 4g, and 2. So yes, it does work. 6g squared plus, and I'm just going to add these here, 7g plus 2, which is exactly what we wanted to get. All right, so I hope this is useful. I will see you later on. Bye.